Well, this is kind of the second in a series of two. I just finished with the problem straight above it, and so if you want to take a look at driving a motorboat, apparently Bill was wanting to drive a motorboat and a jet ski downstream, so, I mean, apparently he just dropped one off, I guess? I don't know. But now we're going to talk about Devontre and riding his bike. All right, so we're looking around. I don't see anything that's weird. And what I'm really hoping for is I'm hoping to find which one of these I use. R is equal to D over T, and D is equal to R times T. Most people tend to remember the last one. I tend to remember the middle one. We're actually going to use the top one. So it just depends. I remember one of these and derive the other two. Some people just memorize all three. Others look at notes. I really don't care which one you choose. Okay, what was his uphill rate? So we're going to start by not reading the problem, but looking at the question. What are we looking for? How do we know when we're done? I'm going to let X represent his uphill rate. Now, doing it this way might actually create more problems in the future, but I'm going to start here. If I think it's going to be easier, I'm going to go back and I'm going to kind of rearrange how I define my variables. But we need a starting point. So let's start there. Once I've defined my variable, I go ahead and I read back through. So Devontre rode his bike uphill 5 miles and then back downhill. The rate at which Devontre traveled downhill was 20 miles an hour faster than going uphill. If it took him 20 minutes longer to ride uphill than downhill, what was his uphill rate? Okay. So I've got some things that I need to pull out here. Luckily we don't have a whole lot of stuff that's extraneous. We can just throw out. This is a key. This 20 minutes longer is a key to which one of these three that we're going to use. And because we're talking about taking longer time, that means that we're going to end up messing with time. So we kind of want that one. Now, this is a problem that I showed you back in previous examples where you have to make sure that all of your units match. 20 minutes is not the same as miles per hour, but yet he's traveling 5 miles and then he has a rate, and it was 20 miles an hour faster downhill than uphill. So it doesn't agree. So we're going to need to make it agree. This is one of those cases where you don't want to use decimals. I need to take 20 minutes and turn that into hours. And to do so, I note that I start with 20 minutes. This is a little thing called dimensional analysis. If you took chemistry class, this is a conversion of units. That's probably where you saw it. You may have seen it in physics. Math really doesn't teach this, typically. So I have 1 hour. I want to go where I want to end up is on top. Where I started from is on the bottom. So I need minutes down here. And I say 1 hour is 60 minutes. The minutes will cancel, leaving me with 20 times 1 over 60, which is 20 over 60. As a reduced fraction, it's 1/3 of an hour. Notice that my hour is still left up top, so that becomes my unit. So anywhere where I see the 20 minutes longer, I'm going to replace it with 1/3 of an hour. But can I use 0.33? You could. You're going to end up with rounding errors. So if your instructor or if the problem says round to the nearest block, then depending on how many threes you take will determine how good your rounding is and how good your answer is. I recommend fractions. It's just way easier. But going back, I noticed that my rate downhill was 20 miles an hour faster. That means that I'm taking my uphill rate in miles per hour and I'm adding 20 to it, and that's going to be my downhill rate. Now, I list these things out to make it easier for what I'm about to do next. I am messing with times. Now, here's the problem that we're going to have. We have a time for uphill, and a time for downhill. And we need to relate these two. Well, we don't really know too many different relations other than equality and inequality. And so I'm going to set these two equal. But you know already by the problem that it takes longer to do one than the other. So what we need to do is we need to figure out, okay, who are we going to add 20 minutes to, or who are we going to subtract 20 minutes from? There are 3 different ways that you can write this equation, and they're all correct. The 3 different ways depend on how you personally view the problem. This is how I tend to view it, but I can see the argument for the other way. And so I'm going to put this in money terms, and that's how I'm viewing it in my head. So I have like $10 over here, and I have $2 more over here, and I want to make them equal. So I know I have 10 here, and I need 2 more over here. Well, that's going to give me a total of 12 over on the right hand side. So what do but I need 2 more. Where does the 2 more go? Well, it goes by adding, because it's more. It goes by adding to the side that has less. So what we need to do is we need to figure out, okay, if he's going 5 miles uphill and 5 miles downhill, so same distance, which one of those will he spend less time doing? Because that's the side that needs the additional time. He should spend less time going downhill. So I need to add 1/3 of an hour. That's this 1/3 that I came up with for the 20 minutes. That's going to make the amount of time that he spent driving or riding downhill the same as the amount of time he spent going uphill. All right. It seems odd because it says longer, so you got to add to uphill, right? It's backwards than it seems. So that's how I do it. Again, however you want to think about it is perfectly fine by me. Just as before, my time. So I have my time is equal to distance over rate. My uphill is going to be different than my downhill. So here's my uphill. The distance is 5 miles. My rate is X. All right, that's fair. For my downhill, I'm getting lazy. Time is distance over rate. My distance is 5. My rate is X plus 20. And now what I'm doing is I'm taking these 2 things and I'm just putting them in the respective slots. So my time uphill is 5 over X. My time downhill is 5 over X plus 20. And then I have this embarrassing plus 1/3 over here at the end. Other than that, it's going to work exactly the same way as before. I just have a little bit extra to do because I have a denominator here. And so by choice, I'm going to clear fractions. So I'm going to multiply everything by the least common denominator. You can multiply them by any common denominator. I'm going to choose the least. But here, it's easiest to do each denominator must be represented. So I have a 3, I have an X, and I have an X plus 20. Remember, I need parentheses because the fraction bar contains the entirety of X plus 20. I am then going to take this whole chunk and distribute it through, and it comes in on the numerators, which means if I have equal numerator and denominator factors, I can cancel. I can do so because my X value won't be 0, otherwise he doesn't move because that's his uphill rate. And because if X plus 20 was 0, then I'd have to have my rate as negative 20. So he's pedaling backwards uphill. That doesn't make any sense either. Besides, you actually want to travel at a rate coming downhill. So X won't be 0 and it won't be negative. What that does is it frees me up to say that X is non-zero, so I can divide by X. Bringing all this stuff over, the 5 and the 3 will multiply. That's going to give me 15. The X's are going to divide out, so that's going to cancel, leaving me with 15 and X plus 20. Over on the right side, the 5 comes in with the 3, so that's going to give me 15. But instead of the X canceling, the X plus 20 factor will cancel, leaving me with 15X. On the third, the 3's will cancel, leaving me with X and X plus 20. So here's my equation. I'm going to go ahead and do another line down, and then I'm going to start my arrows because it's going to take me a little bit. But drawing my distribution here so I pay attention to what I'm doing. 15x plus 300 is equal to 50. I cheated on this, by the way. 2 times 15 is 30. Add the 0. 15x plus x squared plus 20x. Some of my students ask, like, how do you do that so fast? Like, I cheat. Don't tell anybody. All right, so I'm going to go ahead and I'm going to subtract 15x from both sides rather than combining like terms. I'm doing this because I noticed that if I do that, these two terms eliminate. So these eliminate, give me 0. These eliminate, give me 0. Now all I have to do is subtract 300 from both sides. And I finally get 0 is equal to x squared plus 20x minus 300. Yeah, but Phil, I moved everything over to the left. That's fine. It's okay. You'll get the same answers, trust me. I do this because my leading coefficient will be positive, making it a lot easier for me to factor. And now, because my leading coefficient is 1, it makes the factoring decisions much easier. I need 2 numbers that multiply to 300 that subtract to 20. I'm going to start now, because 20 is significantly smaller than 300, and I'm subtracting to get there. Probably going to start relatively close together with my factors. I'm going to take a guess because it's an easy factoring to do. Because it ends in a 0, it's divisible by 10. And so if I do that, that effectively removes a 0 from the 300, giving me 30. And I'm going to test it because it looks cool. And if I take 30 and I subtract 10, I get 20. I just happened to do it. Nice. Okay, so now, if we use our signs to help us along, then that means that 0 is equal to, and we are going to factor this out. We have 2 x's in the front, which means we need an x in the front of each. Now, the 10 and the 30 come into the back, but we have to have different signs. The only way to get a negative is to multiply a negative and a positive, which means these two factors have opposite signs. The sign of the middle term is the sign of the larger of these two. So this is going to be the positive, this will be the negative. And that's my factoring. That means that 0 is equal to x minus 10, or 0 is equal to x plus 30. If I solve both of these, I get 10 is equal to x, or negative 30 is equal to x. However, we have a problem. By the same token that I argued that I could go ahead and cancel out x's up here in the from the very beginning of the equation, I make this argument again. I can't have a negative rate. That means I'm going backwards. And so I'm immediately throwing out that solution as a possibility. Now, this solution was introduced because of the method that we use for solving the equation. This is called an extraneous root. It's perfectly fine. It happens sometimes. It is entirely possible that you do this and develop the equation and you get no solutions that work. It happens, and that's okay too. All right, so let's test this other one. And by test, I mean I'm going to assume that my algebra's good because I'm lazy and I don't want to go back and check it. You really should check it though. But I'm going to take my 10 and I'm going to go back into the problem and say, does it make physical sense? So I'm going 10 miles an hour uphill for 5 miles. Okay, you've got some massive legs, dude. That's awesome. But this could be a very, very calm slope too. Either way, I wouldn't want to pedal uphill 5 miles, let alone do it at 10 miles an hour. 10 miles an hour on a bike though, reasonable. All right, but I turn around and I go downhill at 20 miles an hour faster, so I'm going 30 miles an hour. It's hard for me because, you know, I'm old and overweight and haven't done exercise in 20 years. So riding a bike at 30 miles an hour for 5 miles, not going to happen. However, Devontre is probably in a lot better shape than I am. And so at 30 miles an hour, yeah, you're going downhill. Yeah, you'll probably be tired, but you may be, you know, trying out for either some kind of a bike race or a triathlon, that sort of thing. It's physically possible to go 30 miles an hour on a bike and for a sustained amount of time, especially when going downhill. So I'll believe it. I'll believe it. What was his uphill rate? We're done. And the wondrous thing about that is that we chose to define our x as representing the uphill rate so that when we were done with the problem, we were done. We didn't have to go back and find something else. So there we are, and there's that one. Luckily, that only took 15 minutes. They don't take that long if you just sit down and do them. They take significantly less amount of time, but explaining each and every step takes time. So I hope this was a great help to you. You're going to have to do a few of these to really start to understand why some of the things happen the way they happen. But yeah, they're really not that bad. Just when the numbers get huge, use Google. I don't expect you to factor 31,250. So just go and type in Google, what are the factors of 31,250? Go. And then you can make your decisions. That's just mean. But yeah, I don't write the numbers. All right. Hope this helped. Take care.